Assalamualaikum warahmatullahi wabarakatuh, and very good day. I hope everybody is well and good. So today I'm going to share with you our new chapter on the fatigue failure. So remember previously we have studied failure analysis due to the static loading. For this chapter we're going to see failure that resulting from variable loading. So we call fatigue failure. Fatigue failure is the second major class of component failure. Is due to dynamic loading or variable loading. For example, like the cylinder bar that hang on the wall, and then they have the load that repeatedly force to the bar. So it's like they put the load and release, put the load and release. So it's just like repeatedly. Okay? So whenever it has repeated stress, it's fall under variable loading. If the load is we just put the load on the bar and the load stay there, it calls static loading. However, if we put this load and release, put it again and release, it will make the load it will fall under variable loading. Okay. So we have learned the ultimate tensile strength of material is the maximum stress that can sustain of a material that can sustain before it fail. However, in the variable loading, the material still can fail either the load is still less than the ultimate strength. However, it has to be repeatedly applied to the material. So this is what we call as fatigue failure. So remember this figure. Remember this figure. You do have the stress and strain, and then whenever we do the testing, whenever we do the testing, where is my one? Sorry guys. Whenever we do this testing, we see that the stress is getting higher, and then there are yield strength, there are ultimate tensile strength. So usually after the ultimate tensile strength, the material gonna fail only after the ultimate tensile strength, right? But in variable loading, the fail may occur before the ultimate tensile strength, meaning somewhere here. Okay, and then fatigue is relatively new study or new field in engineering materials. Fatigue can be categorized due to few factors. For example, like stress level. Kalau stress dia tinggi, rendah, kan, it will contribute to different yielding strength. And then the number of cycles, either it is high cycles or low cycles. So high number of repetitions load given to the material, or other factors like stress concentration, knock sensitivity, surface condition, loading size, temperature. So this is examples for the fatigue failure phenomena. This one is you can read in 1981 the flight B737-200 Boeing disasters, where the fuselage broken due to the disintegrated in the middle of the flight. That's very dangerous. Due to what? Due to the repeated load that occur, and luckily they say only one person killed. And this one is very interesting. You may see this bicycle crank spider arm was broken and tore, ataupun kita panggil dia sebagai tercabut terus, patah dekat sini, due to the variable load or dynamic loading. Okay, and then fatigue failure analysis approach. Sorry guys, because saya dah conteng ni adalah lecture notes sebelum ni yang saya buat. Okay, so there are several approach for the fatigue failure analysis. Either fatigue life methods, fatigue strength and endurance limit modifying factors, stress concentration, fluctuating stress, combination of loading modes, varying fluctuating stresses. You will see these several approach in many textbook, especially in the Shigley textbook. But for our case, we will be covering mostly only in these three: fatigue strength, endurance limit, and also the modification of the endurance limit, and then stress concentration. And definitely part of them will use fatigue life methods to calculate the fatigue strength and also number of cycle. So fatigue strength, endurance limit. So in the fatigue strength and endurance limit usually noted as SE, like this one. Okay, fatigue strength pula usually they put as F, fatigue strength. Okay, so these two symbols you may see a lot after this. Okay, for Steele's relationship between the tensile strength and the endurance limit is given by according to ultimate tensile strength. How can we get the ultimate tensile strength? Definitely from the textbook or from the catalog. In dalam buku Shigley ada. Let's say you have steel with specific condition AISI 1060, cauldron or whatsoever, and then your ultimate tensile strength whenever you check in the catalog, let's say less than 14,000 megapascal, you will use 0.5 times ultimate tensile strength, then you can get the endurance limit. Be careful with the prime note here. So the prime note there at the top of S referring to the rotating beam specimen, endurance limit of the rotating beam. Sorry. Okay. Conservationally, for the ferrous material, for the conservative lower bound, this you may ignore this first, but definitely whenever they say ferrous metals, and then they said with specific things, you can use this equation. But have a look, what is ferrous, what is non-ferrous. Okay, and endurance limit can get more in the table A24. Okay, fatigue strength. So fatigue strength, as I mentioned, as F, is the criteria or the character to show the fatigue strength of the material according to number of cycles. So fatigue strength ni asalnya adalah ultimate tensile strength lah. Kalau tak ada load apa-apa kan, cycle pun tak bermula, number of cycles tak bermula, so the strength of the material adalah ultimate strength. However, when you put the load and then you do because load dia adalah repeated dengan alternating, so dia adalah cycle. Cycle 1 ada satu load, cycle 2 ada satu load, meaning cycle 1 you letak load then you release, cycle 2 you letak load lagi then you release. So number of cycles we make the strength of the material getting lower. So dia tak panggil lagi lah ultimate tensile strength, dia panggil sebagai fatigue strength. Okay, because of that thing, fatigue strength ni can be categorized as the low cycle fatigue ataupun high cycle fatigue. Low cycle fatigue ni dia adalah dia punya fatigue strength dia adalah slightly lower than ultimate tensile strength. I will show you the graph after this. In the high cycle fatigue pula, dia adalah apa nama ni? Bila mana cycles dah kita bagi banyak kali, dia akan nampak ada trend that showing the fatigue strength of the material decrease gradually according to number of cycle. So before that, ultimate tensile strength for specific material, for example like steel and cast iron, so they have specific equation that we have to follow. Equal to ultimate tensile strength for steel 3.41 times HB. So HB is what? HB is the either it is correction factor or the variable that usually given. This one based on the standard SAE approximation. So this one true stress value is sigma power F equal to ultimate tensile strength plus 345 megapascal. Then this equation we also can assume if we don't have enough information, for example, we don't know what is its true stress value, we can use this equation as well. This is stress, normal stress, ataupun stress lah, any stress based on the condition of the specimen. E here adalah strain. So strain here could be strain at the failure also can be, like say this one. M is the variable exponent. So fatigue strength, this equation is very important. SF equal to A times N power of B. SF tu adalah fatigue strength, A tu adalah variable, N tu adalah number of cycle, B adalah variables. So you may see this equation a lot whenever kita nak tahu apakah fatigue strength of the material at specific cycle, then kita guna yang ni, kan? Okay, you see A equal to F times SUT, ultimate tensile strength, power of 2, SE, SE tak tahu lagi, SE untuk both A and B is endurance limit that we have to know. F pula, lupa, F adalah fraction of fatigue strength. Right? So you see ultimate tensile strength kalau dia lagi tinggi, so fraction ni makin rendah lah, they're going down. So that's why they say whenever ultimate tensile strength less than SUT, then F equal to 0.9, then you can get directly the F. So this is the SN curve. Okay, so SN curve is very interesting. S referring to what? Referring to fatigue strength. Don't worry about the unit, this figure, because this one is for English unit. Ours usually SI unit, so should be megapascal. But don't worry, the graph, the pattern, the curve, all the materials in this picture exactly the same. So number of stress and fatigue strength. So x-axis number of stress, y-axis is fatigue strength. Then you see low cycle region, high cycle region. Ingat tak tadi kategori fatigue strength ada low cycle dengan high cycle, kan? Okay, and then apa lagi? Okay, masa low cycle, you see without at the original point where there's no load. Kalau ada load sekalipun tapi tak ada cycle, ultimate tensile strength, kan? So material ni dia punya fatigue strength is equal to ultimate tensile strength. However, when you apply load and then the load is repeated, and then you have number of cycles, stress cycle, and then you see ultimate tensile strength is no longer maintained, and then it's going decreasing gradually. And then we no longer call them as ultimate tensile strength. We call the material the strength as fatigue strength. Ni dot hitam ni, kan, fatigue strength. In the low cycle, the equation that we use is this one. And so low cycle ni macam mana? Low cycle ni between tak ada cycle sehinggalah kepada 10 power of 3. Kalau more than 10 power of 3, kita guna this equation. Okay, so definitely AB is taken from this one. Alright, so you may see from 0 cycle until around between 10.6 to 10 power 7, we call as finite life, meaning it will decrease until finally dia tak boleh hidup dah. Kita nampak dia walaupun kita bagi cycle lebih, itu sahajalah the final one, then that's the end of the fatigue strength decreasing. Then you will see that this one according to the in this area, mana ni, in this area infinite life ni, kat sini ke sini, equal to the endurance limit, the maximum endurance limit. So this is the summary of fatigue strength. Please have a look how to get B, and then how to get this one. NE is equal to 10 power of 6 is endurance number of cycles. endurance number of cycle. Okay, so fraction, we get the A, SF equal to this one. Okay, we try this example, fatigue strength and endurance limit. Estimate the fatigue strength of rotating beam. Dia kata rotating, definitely dia adalah variable loading. AISI 1023 HR steel corresponding to a life of 12.5 kilocycles of stress reversal. Also estimate the life of the specimen corresponding to a stress amplitude 252 megapascal. Known properties, ultimate tensile strength. Ni kalau tak bagi tahu kita kena carilah. True stress 805 megapascal, exponent M 0.22, strain at failure 0.9. So given to us, this is N and apa lagi? Okay. Alright. So first thing first, what we have to do is we get the true stress first. True stress, fatigue true stress, fatigue true stress. Okay. I hope you're not the messy here, you will not get confused. I just want to highlight here. So fatigue true stress is equal to stress that given in the question times strain power of M. So you may read further in the page 292. Page 292, equation 9.11. And then you will get apa tu? Sebenarnya they have assumption that failure strain at failure is equal to strain. Then you can get directly 0.9. Power of M given 0.22, and then stress is 805. Where is it? This one, 805 megapascal and 0.9. You get the value. Endurance limit of the rotating beam. Remember dia kata rotating beam kan? Ni rotating beam. So this one we can get this one, endurance limit is 0.5 times 463 equal to 231.5. Ini kat mana pula ni? Ini because you punya ultimate tensile strength is 463, which is less than berapa tadi? 14,000 megapascal, right? So S prime E is equal to 0.5 SUT. So you get this one. And then you calculate B. You put the fatigue true stress. You put the endurance limit of the rotating beam. You put the endurance limit number, cycle number, and then you can get B. How can they put NE equal to 10 power of 6? This one is ideal number of cycle for material. So usually 10 power of 6. So you just put 10 power of 6, although it's not given in the question. And then you calculate F. The same thing, you calculate A. And then you put everything in this one. Kan kita dah ada A, kita dah ada B, kita dah ada N. Then you get the fatigue strength. This one, fatigue strength. And then you calculate N, sigma A over A, power of 1 power over B. Then you get number of cycles. So how many cycles before failure at fatigue strength at 500 megapascal? Senang je lah ni. So you just replace fatigue strength 500 megapascal dalam ni, then you get the number of cycle. Okay. Alright. That's all for now. See you in the next video. Thank you.